HTTPS. We all want it and we all should be using it, whether for demos and obviously for production applications. In this video, I'll be going through all the concepts of HTTPS, what is a certificate authority, how it works, how we can actually generate certificates, self-signed certificates, and using a certificate authority for Kubernetes cluster and deploy a sample application and get HTTPS for it. So without wasting any time, let's get started. But before that, a huge thanks to Commodore, Avesha, Sysdig, Instruct, Slim AI, who are the members and they support my work, and that is why I am able to produce this content. But there's nothing about them in this video. This video is all about HTTPS, Ingress, Kubernetes, TLS, Certificate Authority, and everything. So let's get started. So first, we'll get through the theory part and then we'll do the hands-on demo. So we'll try to simplify the concepts. Let's start with the first one, like how HTTPS actually works. Now, very simply, how HTTPS works is, so there is a client, that is your laptop or your work machine. From there, you hit a request on a particular website, for example, kubesimplify.com. Now, this request goes to a server where kubesimplify is there, and then it will respond with a certificate and a public key to the client. And then the client will verify whether this key came from actually this particular server, and then it will send its own key by using encryption and encrypting that with the key sent by the server. And once it goes here, now since the private key of that particular public key is on the server, so it will decrypt that and they both will end up sharing a key that only they know. And therefore, all of their communication after this will be encrypted. So it's the encryption, the key, and the locking, all these mechanisms is basically real world scenarios. So for example, you have a house and your house is having a lock. So you are having a house and your house is having a lock. Everyone can see the lock. Everyone can see the lock, but only you have the key to unlock it. So basically what public-private key would mean here in this particular case is, so the lock is the public key. So the lock is the public key because everyone can see this. Your public key is visible to everyone. But the private key is the actual key that is used to unlock the lock. So that is how you have the public-private key pair. So you'll be having a public key that is shareable, you can share it, everyone can view it, and then you have the private key that is used to unlock it. So in software, we create public-private key pairs, and that is how we talk in these terms. So this is the mechanisms. And all of these are actually nothing but mathematical calculations, how these things happen internally behind the scenes. But we are not going into that. Now let's take the example that we just did of, the client connecting to the server, the kubesimplify.com is step by step. Now you have the client. Now client is the actual machine that you're in. And then you're hitting kubesimplify.com and it's going to the server. So the first step is client is trying to establish a connection with the server. Now what server does is it sends a certificate. So it sends a certificate, and we'll tell more about like how this creates actually the certificate. So it sends the certificate that is having a certificate and its public key. It goes here. Now the client has to actually verify. So it checks if the cert is signed by the correct CA. So there are some certificate authorities that are publicly available. So the client will be able to check whether this particular server is signed by a certificate authority. Once it has that sort of verification, so certificate authority check is done, it will encrypt its own key using the public key that is here and send to the server. Now, since the server is having the private key of its own public key because it is having a key pair, so it will decrypt the key and get this particular key on this system as well. Now, this particular key is now present on both client and server. So both systems can be used for end-to-end encrypted communication. So that is how this will work. Now I mentioned something about certificate authority. What is that? What is a certificate authority and why do we need it? So a certificate authority is a place to store, sign, and issue certificates. Like, for example, you have a Google Certificate Authority or non-profit certificate authority like Let's Encrypt, which we'll be using heavily in today's particular video. So how do we get these certificates, and how does certificate authority plays a role in this? Let's say you have a website, xyz.com, and you want HTTPS for that. So what you will do is you will request a certificate from a certificate authority, and certificate authority will be issuing you a certificate based on certain steps. Now let's take, for example, a very simple example, like you have a server, and you have Nginx running, or even Mastodon, just giving you example. So you have some application that is running, and then you have exposed it like on port 80, and your website is pointing to this particular IP address, the public IP of this particular server. So whenever you hit xyz.com, it goes to this particular server. Now you want to have the HTTPS for this particular server using Let's Encrypt. So let's see how we can do that. So you have the server, the website is running, the Nginx application is running on port 80. So what you will be doing is you will be installing something called certbot on this particular instance. And for example, this particular instance, in this particular scenario, we have taken it as Ubuntu. So you have Ubuntu, you do apt install certbot. So certbot get installed. So once you have certbot installed, you can use that to generate the certificate, and you will be obviously giving out the domain, all that information, accepting the license agreement, and then it will be generating the certificate chain called full chain.pem, private key, and all those. And then you need to update your server configuration so that it also serves the location where the certbot is generating the certificates. And then certificate authority like Let's Encrypt in this particular case will issue the challenge, and it will be fulfilled, and it will give you the certificate which is signed, and that particular certificate will then be sent whenever the request will be coming to this particular server for that particular website. So that's how it works. So all in all, to enable HTTPS on the website, you would need to get certificate from a certificate authority. For example, in this case, it's Let's Encrypt. That requires you to demonstrate the control over the domain first using the software which is running on your web server. And like I said, if you have the access to the shell, it's you can use the certbot Acme client. Acme is the protocol in this particular case that will be automating the process. And if the shell access is not there, you can use built-in support from the hosted providers which are there. And if both of these are not there, then obviously you have the manual mode. And what happened in this particular scenario was the Let's Encrypt and Acme protocol is aiming to automate the process of obtaining a browser trusted certificates for HTTPS server without any human intervention. And this is being achieved using a certificate agent, where in this particular case it is certbot, and it is interacting with Let's Encrypt CA to validate the domain ownership and request, then renew and revoke certificate. So you can do all these three process which is there. And the agent also proves, in like I told you, it issues the challenges. So the agent proves that it has the domain control by solving those particular challenges. For example, provisioning a DNS record or HTTP resource. And once everything is validated, the agent requests the certificate and sends the PKCS, all those certificate signing request, which is very important. Signed with the authorized key pair. So it sends the CSR with the key pair, and then it will be having that certificate. So I hope you have a general idea now, like how this certificate is working, how key pairs, what are the key pairs. If you have a non-HTTPS website, then how you can request the certificates from the certificate authority, for example, on a web server. And also like how there are certain challenges that the agents sitting on the servers can fulfill and get those certificates. Now, Let's Encrypt is very commonly used when it comes to HTTPS, putting HTTPS using ingress within Kubernetes. So now what will happen is you have a Kubernetes cluster. In the Kubernetes cluster, you have ingress controller, and you have something which is called cert-manager, which is installed on the cluster. Now, cert-manager is able to provide all what we did as certbot. So cert-manager will be doing that. That will be creating a certificate signing request. We'll be creating an issuer, and then it will be automatically creating a secret for us. And then that particular secret will be used, and then you'll be creating an ingress. And once the ingress is created using the TLS, when you hit the domain for which the certificate was issued, you'll be getting a HTTPS. Now, we'll do it hands-on. But before that, let me show you how you can actually use self-signed certificates. So either you can automate the complete process, but we'll take a step back and first we'll do the self-signed certificate thing, and then we'll do the cert manager thing. So let's now get into the demo, because by now you should be having enough theory to understand the rest of the video. So I have this particular repository, Cube Certs, and I have first the self-signed.md. So we'll be doing that. Now for this, you'll be needing a Kubernetes cluster, and I already have a Kubernetes cluster created. You can use any Kubernetes cluster. So in this case, I have kubectl get nodes. So the cluster is there. Now before anything, obviously I need to install the ingress controller. So we'll do that. This is nothing but the command to install nginx ingress controller. So it is creating bunch of things, namespace, service account, the binding, service, config maps, and the deployment, etc. So kubectl get pods -a. It should be ready in some time, and we can see it's already in running state. Cool. And now the first step is obviously to obtain the key pair, to generate the key pair that we want to use, because we are doing all the steps manually. We'll automate everything later on. So we'll paste this. Just make sure we use this particular common name as the right domain. In this particular case, we'll be using the nginx ingress DNS. So let's use that. And the rest of the things is nothing, just, getting a self-signed CRT and the key, which is there. So let's press enter, and it has generated a self-signed TLS cert and a self-signed TLS key. Now, the next step is actually to create a Kubernetes secret of type TLS, where we'll be giving the key and the cert that we just generated. So let's do that. You can see the secret self-signed TLS is created. Now let's create a deployment and a service. Very simple. Hello deployment. And then we expose that on port 8080. And you can see it is exposed. So we can just do kubectl get pods. We can say pod is running, kubectl get svc. Our service is running. So we have a pod, we have a service of type cluster IP, because we didn't type anything for the service type. So by default, it will be using cluster IP as the service. Now is the time to create the ingress. So we use vi ingress.yaml. We need to change a few things. So I have made some changes. First, I have added an annotation for using the ingress class as nginx, and then TLS changed the hosts, and then the secret name I have added, and again the host. So basically, this is an ingress. Ingress is a Kubernetes object, but it will only work when you have the ingress controller. You can use any ingress controller like traffic, ingress, and so on and so forth. And then you have to define the metadata. And this is important because you're telling which ingress class to use. In the spec section, you will be having TLS, because this is important when you want to enable HTTPS, and you give the hosts and you give the secret name that you just created. And then you specify the rules and the path. Basically, what would be the path when you hit a particular service, like the path/demo, when you hit that, to which particular backend service it should be going, and to which particular port number it should be going to. So that is it. We'll now apply it. kubectl apply -f ingress. Ingress is created. kubectl get ingress. Now, once the ingress is created, we can do a curl on that. So let's do curl -v -k HTTPS and put our name in /demo. because that is what we specified in the ingress, and you can see hello world. So we are successfully able to hit this particular endpoint. We can actually do that in the UI as well. So when you hit this particular URL in the browser, you will see that the connection is not private. And this is because when you open the certificate, it will say self-signed root certificate. Now, if it would have been from a known certificate authority, then it would have automatically been trusted. But what we'll do in this particular case, we'll say that visit this website. And since we haven't put /demo, that is why it is getting this, but we'll be getting HTTPS. And you can see that Safari is using an encrypted connection to our specified domain, which we are using. So that's how you can use self-signed certificate. It is okay for the development purposes and things like that. But when you are actually deploying applications to staging and production, you should be using something called Let's Encrypt. And let's see how we can do that now. So first step would be to install cert-manager. So let's do that. So we'll go to cert-manager install. We'll install cert-manager documentation. It's a kubectl apply. We'll use this and apply. Cert-manager will be installed in a few seconds. It is already installing certain custom resources. Some of the main ones are actually the certificates, the issuer. And once cert-manager is deployed, what we are going to do is we'll go back to our repository. So our repository is having a lot of things, but the main thing is in the deploy. So in the deployment, let me explain this first. So it is a demo deployment. So it is a deployment with the name called kubecerts and in the namespace demo. So first we have to create the namespace demo. So kubectl create namespace demo. And in demo, it will be deploying a deployment with a particular image that is there, container port. Next is again simple, the service. So you have a service. You can give it cluster IP or node port. That should be fine. Now comes the cert-manager. Now here it is doing the magic. So first we are doing a cluster issuer. So there is an issuer on the namespace level and the cluster issuer on the cluster level. So we are using cluster issuer with the name called kube issuer, and we are specifying the ACME. So we are using ACME protocol over here. We are specifying the server URL for ACME, which is the Let's Encrypt. So these URLs you can get. Then you have to give a demo in email, not a demo email. Here I have used demo email, but you have to give a email, and then the name of the secret to store the ACME account private key. So I have given it the name kube issuer. And this is the type of challenge which is there. So we are using the HTTP01 challenge, and we are specifying the ingress class to be Nginx. Then comes the certificate. So we are again using a custom resource called certificate from cert-manager. And here we are giving it a name in the namespace demo. So for the certificate, we are using secret name demo. And for the issuer reference, we have given the reference of the cluster issuer that we created just above. For the common name and DNS, this we have to change as per our own Nginx DNS, which is there, which we'll be changing. And then is again the ingress creation. And here we just add one more line, which is the cluster issuer kube issuer in the annotation section. And again, we have to change the host and the hosts over here. So what we'll do is we'll copy this completely. I actually have it in the previous repository. So we'll go to the deploy folder and we will edit here itself, and we'll copy the DNS name. So let's do that and change these things. So demo and demo for the certificate and also for the ingress. So first we'll see kubectl get secrets -n demo. So we don't have anything yet. Kubectl get all -n demo. And you can see we don't have anything in this particular namespace. Now we'll deploy that kubectl apply -f, and we'll also check the cert manager ports. Get ports -n cert manager to check everything is running. Yes, everything's running perfect. So let's do kubectl apply -f deploy, and it will create all the resources that I just explained: deployment, service, cluster issuer, certificate, ingress, and all these things. You can actually do kubectl get certificate in the demo namespace, and you can see right now it's false. It is fetching, getting all the details, fetching, and the challenge is getting fulfilled. Then only it will issue the certificate. In some time, it should be true. Yes, they both are ready now. And then kubectl get secrets -n demo. We'll be having a few secrets like demo that was created as a TLS secret with the certificate. So you have everything, all the secrets in place. So kubectl get ingress, and we should be able to hit that ingress now. So let's do this. You won't be able to see it won't ask you for accepting the certificate or trusting the certificate, because it is already verified using the certificate authority. So you can see the connection is secure, and you can see certificate is valid, and you can see issued to, issued by, and you can see the organization, let's encrypt. So you will be having all the fingerprints, validities, and everything. So, but this is how you will be able to do it in a much cleaner way than doing it manually. So cert manager proves to be a very useful tool when you want to issue certificates for your web services or for your applications that you are deploying in your Kubernetes cluster via the ingress. So in this video, what we have seen is what is HTTPS, how HTTPS works, the key and the locks, what is a certificate authority, how a client actually verifies the certificate authority from a particular server, because when the request goes, it comes back, and then it automatically uses that public key given by the server, tries to connect with the certificate authority and check whether that certificate authority actually signed this particular server. So it knows that it is coming from the right server, and then it encrypts a key and send that to the server, and then the server will use the private key and decrypt the key which was sent by the client, and then both the client and the server are having that key over which they can communicate in an encrypted manner, which is what HTTPS is meant for, to having the end-to-end communication is encrypted. So it is secured. And then when you are doing it on a server, you can use tools like certbot to generate and automate the process of generating, revoking, and renewing the certificates for your application from the certificate authorities, like Let's Encrypt. When you're using tools like Kubernetes, you'll be having Kubernetes, then you'll be installing an ingress controller, and with the ingress, you'll be able to route the traffic to a particular URL. But to generate the certificates, either you can do it manually using OpenSSL and creating the secrets and using it carefully inside the TLS section of your ingress, or you can use tools like cert-manager to do it for you. So you'll be have to creating the custom resources, but that's a much more cleaner way of doing it. So you'll be creating the issuer or cluster issuer, then the certificate, and then you'll be using the key that you have defined in your certificate, and you should be good to go. When you hit the ingress, you will be getting absolute HTTPS. So stop using HTTP for your demos and just simply use HTTPS. Like, even for small demos, make sure you're using HTTPS. It's pretty simple. I know many people are using Kubernetes for their demos. So I hope you learned from this particular video about certificates, how to manage them, what are they, using Kubernetes, self-signed certificates, and the automated way of doing it using cert-manager. Again, a big thank you to Commodore Avisha System Instruct Slim AI for supporting me in the work that I am doing. And I hope you understood the certificates in a much better way through this particular video. If you like the video, please do not forget to like, share, subscribe, and comment your way of doing things. And yeah, make sure to subscribe to the channel. Like, it keeps me motivated and doing more and more stuff. And yeah, there are big things planned for Kube Simplify, and we'll keep pushing out great content like this. just need your support in that. So thank you all, and make sure you check out all the people I have mentioned. Commodore Avishya, Tick, Instruct, Slim AI. All the links are in the description box. The more you visit them, the more they'll support me. As simple as that. So I hope you learned something from the video. If you try out the demos, I'll put the repo link also in the description. If you try out all the demos, do tag me on Twitter @SayamPathak, and I'll be happy to retweet, comment, and take your issues. Thank you so much, and see you in the next video.